the middle ground here of, do I wear the glasses and just hope they don't fog up, or do I just sacrifice, the power of sight? I don't know. I'm just dealing with it. So, scatter plots, correlation, causal relationships. Scatter plots are just plots of two variables. All right, so one variable against another. We've been doing that all year long. Just we never called it a scatter plot. Whenever you plot an ordered pair, like 1, 2, that's a point. Now, we've been creating functions out of those, but if you just plot them as scattered points, that would be a scatter plot. All right. Correlation is a number that tells us how strongly two variables are related to one another. All right. So, correlation itself is the relationship between two variables, but for our purposes, correlation, we're going to come up with what's known as a correlation coefficient. That's going to give us a numerical value. All right. But just because two variables are related to one another doesn't mean one actually caused the other to happen. All right. So you can think about plenty of instances in which one variable causes another to happen, but there are some variables that are related to one another, but not necessarily a causal relationship. All right. That's the beginning of the investigation. You find a relationship and say, oh, I wonder if one caused the other to happen. So let's say you overpacked your car. You're doing a long drive. Maybe you're driving down to Florida for a vacation. You overpacked the car and you noticed that you're stopping more frequently to get gas. So your fuel economy is impacted in some way. All right. So you suspect that there's a relationship. So maybe you collect some data. I would not imagine that in a car ride down to Florida, you're going to whip out the old graphing calculator and run a correlation coefficient, although you would have the time. You could determine whether there's a strong relationship between the weight in the car and the fuel economy. Right? How many miles per gallon you're getting. All right. So you run that analysis and you see that there is a relationship. Now you want to know, what's the causal relationship? All right. Is the amount of weight in the car causing an impact in the fuel economy? It sounds likely, but that's where the logic comes into play. Logic and or common sense. Mostly common sense. But that's what you start looking at. You take into account, well, first you have a suspicion, then you take into account the R value, whatever the correlation coefficient is, and then you use your senses, logical reasoning, and just good old intuition to determine whether one is causing the other to happen. All right. So, if you have a protein shake before you play a big game, and in that game you score 3 goals, did the protein shake cause you to score 3 goals? Maybe, maybe not. Doubtful. But if every time you have a protein shake before a game, you score 3 goals, you're going to start getting suspicious. All right. So these are some things that we take into account. All right. I have some basic scenarios here. At one time, some of them are a little kind of frivolous. At one time, there was a strong positive correlation between the number of mules in the state and salaries paid to professors. The more mules, the lower the salaries. I would not imagine that the mule budget is impacting how much professors at whatever college are being paid. So it just seems like that's a coincidental relationship. So I wouldn't say that that's causal. I don't think that there's anybody that's watching the news right now saying, oh, New York just bought 1,000 more mules. Salaries are about to go down. It's not really like that. All right. Strong positive correlation between the number of fire trucks in a borough of New York City and the number of fires that occur there. That's a tricky one. You could actually go either way with it. I'm going to say no, but you could go either way because you could have what's called a lurking variable. So let's say you're just looking at it simplistically. Fire trucks do not cause fires. Right? It's not like a fire truck comes rolling down a street. You're like, oh, we're about to have a fire here. That's not how it plays out. All right. They don't prevent fires either. Right? The fire is going to start whether the fire truck is there or not. They're there to put out fires. Right? But if you look at it from the perspective of more fire trucks means more firehouses, more firehouses might mean more fire prevention programs. More fire prevention programs means more people educated on how to prevent fires, which would then lead to less fires occurring in a particular area. Then you have a causal relationship, but it's a chain of causality rather than just a direct link. We're looking for a direct link, so that's why it gets the no. All right. Strong positive correlation between foot size and handwriting quality. I mean, that gets a no just because. I mean, if you could think of any relationship between foot size and handwriting. Now, hand size and handwriting quality, maybe. I don't know. I still wouldn't even necessarily establish causality there, but it's more likely for that than it is for foot size. An increasing number of hours kids watch TV positively correlates with decrease in SAT scores. Right? So we're looking to see if one variable causes a change in the other. It could go the other way around, where you look at it and say a decrease in SAT scores positively correlates with the number of hours of TV a kid watches. Aside from that, there's only so many hours in the day. Yeah, so you take the number of available study hours and you start cutting into that, whether it's SATs or just a simple math test. If you cut into the amount of time that you have to prepare for any assessment, it's going to impact your ability to be successful on that assessment. Okay? And this is on average, because we're talking about kids in general. We're not just talking about you as an individual, because you may not need to study at all for a math test or SATs. You may need to study a lot. Somewhere in the middle, most of us live, but odds are, whatever the leisure activity is, TV, video games, just screwing around on the phone, doesn't matter. It's going to impact something because it's just time that's being used. All right. So hopefully that helps with the causality thing. Yeah, assuming you're paying attention, because I see a lot of people smiling at their laptops. Anyway, correlation coefficient. A correlation coefficient, like I said, is a number between -1 and, well, I didn't say the -1 in one part, but it is a number that talks about the strength of the relationship between two variables. All right? So -1 and 1 are the perfect relationships. On your paper, this one was incorrect, so that's a typo for somebody. It should be a straight line downward trend. All right? So if the data points form a perfect straight line, then it's a perfect positive linear correlation. It's just a question of whether it goes in the upward or downward direction. All right? All right, so you'll have to know those relationships. Now, linear regression is the line that best fits the data set. So what we're going to do is use a graphing calculator. I don't even know what I hit there. We're going to use a graphing calculator to come up with those linear regression equations. We're also going to come up with the correlation coefficient. All right, correlation coefficient, again, is the number that tells you the strength of the linear relationship, and the linear equation that emerges from that is known as the linear regression equation, or line of best fit, or the trend line. So in our calculators, we're going to hit stat edit. I have some data values here, so what I'm going to do is go right up to the column heading, hit clear, and enter. And then type in my data points. Just waiting for everybody to get on board here. Just because it's not the most intricate process, but it does take a minute. And if you don't have the data in right, it just tends to fall apart. All right. So once you have your data in, you're going to hit stat, and we'll do the scatter plot in a minute. We'll do that together, but you're going to hit stat calc 8. All right. So stat calc 8. So stat, right arrow to calc, right on down to 8. It says linreg a plus bx, and you'll see that there's another one that says linreg, option 4 ax plus b. Honestly, you can go either way, stat calc 4 or stat calc 8. The thing that makes stat calc 8 beneficial is that it puts the constant term first, which is generally what we want in contextual problems. So, that's the idea there. So when you hit enter, it'll bring you to this display. You should have X list, Y list being L1, L2. Under store regression equation, we want that to be Y1. All right, so that won't be plugged in for you. The first two is held over from whenever the last time you ever use this function. The default setting is L1, L2. So if you never used it before, it'll stay as L1, L2. But if you use one of mine, some of my stat students need to change it for certain types of problems, so it might be different, right? So the L1, L2 you get by hitting second 1, second 2, and the Y1 you get by hitting alpha trace, and then Y1, all right? So L1, L2, then store regression equation, you hit alpha, trace, Y1. And then we hit calculate. Now, you should at minimum have the A and B. You may not have the R squared and the R. I'll show you how to handle that in a minute. If you don't have the R squared and the R, there's a certain function that we have to set up on your calculators to get there. But you see in this problem, we need not only the A and B, but we need the R value. So we'll have to get there, but just kind of go with it for a minute. They said correlation coefficient, that's the R value, to the nearest thousand. So that's 3 decimal places, so 0.948. The regression equation, the equation of the line of best fit, we have it in the form of y equals a plus bx. So y equals, they said to round your y-intercept, which is the a value, to the nearest integer, and the slope to the nearest hundredth. So 19 plus 1.16x. All right, so we have all those important values. Like I said, we'll create the graph too in a minute, but let me show you, if you don't have the R squared and the R values, how to get that. Also, you're going to need to know that for the regents anyway, because the first thing that they make you do is reset your calculator, right? So, and that's so that you can't store like inappropriate apps in there, you know. So obviously it's a cheating thing. So they'll make you reset your calculator, which is going to shut off the diagnostics. So we need to know how to put those back on anyway. All right. So what you do is you go into the mode function. You hit mode. You see next right at the bottom of the screen there. Go right on down. You'll see one that says diagnostics, stat diagnostics, off versus on. Just make it say on. So right arrow to on, hit enter, and then when you run this function, it'll bring up your R squared and your R values, respectively. All right. So I'll just show you. If I had my diagnostics off, this is what it would have looked like. Stat calc 8, alpha trace y1. This is all I would get. All right, I wouldn't get the R squared and R, which I need, you know. But then when I go down and I put my stat diagnostics on, run the same computation again, stat calc 8. Now I get the full slate. All right. Now the reason we did the store regression equation, it actually ended up not being necessary for this problem, but it's a good habit to get into because it'll almost always be necessary. The store regression equation takes whatever that line equation is, it takes its most exact form and puts it into y equals. All right, so in y equals, I have the unrounded version of the answer to the second part of this question. All right, so if I wanted to look at the graph or get a table of values, I can easily get that information. All right, so I could plot that line pretty easily now. I mean, the numbers aren't pretty, but I can get what I need out of it. All right, so let's get the scatter plot here. Scatter plot is just x value comma y value. So 26 comma 49. $28 comma 50. 30 comma 57. 32 54. 34 60. 35 58. 37 64. 38 66. 41 63. And 45 72. Right. Going by twos, so it's really not terrible. All right. But the benefit of doing the store regression equation is that now if I needed to plot my trend line, I could do that pretty easily. All right. Now, you see these little breaks here in the graph? That tells us that we're not really looking at the y-axis here. We're looking at like everything from 0 to 20 is kind of condensed into this little space here. All right. So plotting anything from 0 to 20 wouldn't be really useful. What I'll do is I'll grab the first point at the x value of 20, which would be 20 comma 42 and change. Even that's a little low because the lowest point that I have here is 44. I mean, I suppose I could ballpark it, but what I can do is grab something that I know is on there. So at 22, I have 44.651. So that would put me about right here. And then I could grab something a little higher down the line. So maybe like, well, I can get 48 because 42, 4, 6, 48. So I'll run down to 48. That's going to put me at 74. A little over 74. Maybe that's a little too high. So at 47, I like 46 a little bit better. 46 gives me 72 and change. All right. So that's going to put me right about here. And then I can connect, and that gives the trend line. Y equal to 19 plus 1.16x. All right, so it's a nice, easy way to get the graph without having to do too much work. Because, you know, slope and y-intercept are great. They're very helpful if the numbers are nice and the graph is scaled reasonably. But this one starts off at an x value of 20 and a y value of 50. So the y-intercept isn't really that helpful, and I'm not too eager to plot a slope of 1.16. So I need something else. So what I can do is use that store regression equation to let the calculator give me some coordinates that I could then plot, and now I have my trend line. Right? Now, I just realized that the question never asked us to plot the trend line, so that's a typo for somebody. Right? So number one should ask for the trend line. Right? So if somebody needs a typo. Yeah. Yeah, just add it from the domain. So looking at the x values, so anywhere from 20 to 46, 48. I grabbed a couple of coordinates, plotted them, and made a line out of it. All right. Good question. So the next one, generally the fuel efficiency of a car changes with the weight of the car. All right. Survey of some cars with their weights and gas mileage are shown below. The weights are in thousands of miles. Sorry, thousands of pounds, thousands of miles. The mileage is in miles per gallon. We want the least squares line, same thing as linear regression line, same thing as trend line, same thing as line of best fit. All right, and then a follow-up question that we have to answer. So the first step, and probably the most crucial step, is typing in the data. So I go to stat edit. I have all this data in here. I want to wipe it out. So I hit the up arrow, clear, enter. Up arrow, clear, enter. Up arrow, clear, enter. Then we type in the information. You don't want to hit delete. If you accidentally hit delete on one of the column headings, it's not terrible. It's not irreversible or anything. I'll just show you real quick. Say you hit delete on L1 instead of clear. L1 disappeared entirely. It's like, oh, now I don't have L1 anymore. If you kind of play that out in your mind, you'll realize that you're going to run out of L's very quickly. Right? Because there's only 6 of them. Well, 5 of them, I guess, in mine. But usually 6 of them. So it's like, I don't have any lists. What do I do? Well, the way to bring it back is to hit, well, the opposite of delete is insert. So second, delete. It'll create a new column that you would just name L1. Above the 1 in blue here, it says L1, so second 1, and it comes right back. But that doesn't stop you from having that moment of sheer panic where you think you broke your calculator. All right, so we type in our data. Carefully. So you have your information in, do a quick double check, make sure you typed it in correctly. We're going to find the least squares line. So I'll quit out of here, second mode. Stat, calc, 8. Under store regression, we're going to hit alpha, trace, y1. All right, so same setup every time when you do your linear regression equation, which is nice. Predictable. When you go to calculate, you should have everything you need. All right. So they said round the coefficients to the nearest tenth. So y is going to be equal to 68.1 minus 8.1 x. Now this is a function, it's a linear function, so we could write it as y of x. And the reason I bring that up is because in the next part of the problem, they ask us to make a prediction. If a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency? All right. Now the weights are already in thousands, so when it says 4,300 pounds, that's really saying the x value is 4.3, but it's really saying evaluate this function for when x is equal to 4.3. All right, so the way we do that is in our home screen, hitting alpha trace y1 and typing in the 4.3. And they said round to the nearest integer, so 33 miles per gallon. All right, but that only works because we stored the regression equation into y1. In fact, if you hit y equals, under y1, you see the unrounded form of the regression equation. All right, it's all there in its full glory. That's the only way you get an accurate answer when you do the home screen alpha trace y1 bit. All right.